Okay, so we are discussing here the multiple choice questions from linear differential equation, now from BS Grewal only. So question 1 to 9 completed by Sahitya. Okay, let me cross check, and if anyone have any doubt in any of the question, we'll discuss that in detail here. Okay, so question number 1 is we want a complementary function for d raised to 4 minus a raised to 4. So this is one differential equation which have the, you will observe one factor will come d square minus a square, other come d square plus a square. It is no need of this synthetic division side here. Okay, so it is just like a d square minus a square. So d square bracket square minus a square, a square minus b square form. So plus or minus ai are the root and plus or minus ai are the root. So it is very straightforward without synthetic division, and you got the correct answer. So yes, you can do it both of the way. That's okay. So that's a correct answer there. Question number 2. Now the pi for sine 2x. Yes, whenever there is a trigonometry term, we know we replace d square by minus a square. We get a linear term in the denominator, rationalize, and then again we replace the d square. So that's correct, and derivative of sine 2x as 2 cos 2x plus 3 sine 2x. And everything is fine. That's correct. If you have the doubt, yes, you can ask in between. Okay, so you can stop me at any time. We'll discuss that solution detail. Question 3. We want here pi for this function. Now constant is there. So whenever constant is there, yeah, you can take e raised to 0x there, and so we can replace d by 0. Replace d by 0 for a constant to get a yp, and you get that yp there. So that's the true correct answer is 6. Okay, so that about question 3. Question number 4, the Wronskian for the function x and e raised to x. So we get y1 as x and y2 as e raised to x. So that Wronskian will be a determinant, and we'll get yes, e raised to x into x minus e raised to x. So that's the answer. The answer is correct, e raised to x into x minus 1. So this is also correct there. Question 5. Y double dash minus 2y dash plus y is equal to x e raised to x, and we want CF only, so there is no worry about RHS now, just we have to think only on LHS, and we want CF for this. So d square minus 2d plus 1, so 1 is a repeated root, so c1x plus c2 e raised to x. That's correct answer again. Yes, any doubt? Anyone have the doubt in first 5? No. Sixth, we have the fourth order differential equation. So it will have 4 roots. So one of the root d is taken common, so d is a 0, remaining is a cubic. And if you have the good observation, you can observe that it is a perfect cube of a d minus 2. So 0, 222, that's the root. So CF is a C1, C2 plus C3x plus C4x square into e raised to 2x, and that's correct. Okay. There is an alternative way also that you can do a little bit in smart way. If you have the differential equation and the CF is given as MCQs, so you will have 4 answers there. You will get indirectly the roots there. For example, if this option is one of the choice, suppose this is only one of the choice, so this indicates the root should be 0, that is c1 into e raised to 0x is there, and e raised to 2x, it is a cubic quadratic term is there, so it is a 2 2 2. You have to cross check whether these 4 values satisfy this equation or not. If it satisfies, then this is a correct one. So you can go by hit and trial also, that reverse way also. So sometimes you can think little smarter, and you can go in a reverse way also, but yes, the main part is, yes, if you go this way, then only means whenever there is a subjective paper, then this is only the way you can go there. Okay, for multiple choice questions, sometimes you can use the tricks, shortcuts, and go ahead here. Question 7. D square plus a square of y equal to, we want pi for this, and yes, denominator comes in 0, and that's the answer, minus x cos x upon 2a. That is correct again. Integration of sine is a minus cos ax upon a. That's correct. 8th, here d square minus 2d plus 5 bracket square is given. So bracket square is given. So obviously find the roots of this first, and then it is a repeated root. So you will observe 1 plus or minus 2i and again 1 plus or minus 2i. So this is only, I think this is the first time you came across complex repeated root. Complex repeated root. So here complex repeated root, the CF is written this fashion: e raised to x c1 plus c2x cos 2x plus c3 plus c4x sin 2x. So that is alpha plus or minus I beta, and if that is repeated, e raised to alpha x c1 plus c2x cos beta x plus c3 plus c4x sin beta x, and answer is correctly written there. Okay, so this is the first example I will tell you where you came across complex repeated root. This is a very rare situation. Generally, rarely the question of fourth order is asked in the exam. If it is asked, again it is repeated, that's again a very rare chance. Last question from the first set, y double dash plus y equal to 0, and we want the solution with y0 is 1. So we want some particular solution here. So d square plus 1, so plus or minus I, so this is the CF. So c1 cos x plus c2 sin x, correct? So first condition says when x is 0, y is 1. So that's written here. This y0 equal to 1 means at x equal to 0, y is 1. And if we replace x0 and y1, cos 0 is 1, sin 0 is 0, we get c1 as a 1. But second condition is when x is pi by 2, y is 2. So when we replace x by pi by 2 in this equation and y by 2, we get c2 as a 2. And if we replace these values, we get a particular solution as cos x plus 2 sin x. So all questions completed by Sahitya, they are correct. None of all the answers are correct there. If anyone have a doubt in any of these first 9 questions, you can ask quickly. Otherwise, I will move to the second set. No doubt? Okay, good, Iftikhar. Now I think this 10 to 18, these are completed by Neil. I think, yes, it is by Neil. So let me see these questions. Now here we are given, this is the general solution of. Now reverse question. If you see the first 9 equations, in first 9 we are given differential equation and the question is about the answers. Now the answer is given and the question is which one is a corresponding differential equation. So this term itself gives us the solution. First of all, 2 arbitrary constants, so answer should be the, no, sorry, 3 arbitrary constants, C1, C2, C3. So differential equation should be of third order. All options are of third order probably there, or if you have the options there. So yes, it is third order and one of the root is 2. So d minus 2 is a factor. D minus 2 into, here you can take this as a factor. This is minus 1 plus or minus root 3i. Okay, so I think he gone in the reverse way. Neil started from this differential equation and he tried to get the answer solution here, and then he says that way. So that's one way. First of all, you have to find out if it depends on options mainly. If you have the options, then you can check first whether 2 is a root. If 2 is a root for all the 4 options, then you have to go for this root. So you have to check which differential equation of the root minus 1 plus or minus root 3i, that way. So the correct answer, 11th, d square plus 1 bracket square equal to 0, and we want a solution again. So first thing, d square plus 1, if you factorize, it is plus or minus I. Plus or minus I is a root and plus or minus I is a repeated root. So complex repeated root. Same case that I think in question number 8 or 9 there. So C1 plus C2x cos x plus C3 plus C4x sin x. That's the correct answer again. So this is one extra formula you have for complex repeated root. So this is a second example on complex repeated root. 12th. If we have d2y by dx square plus y is equal to cos hyperbolic 3x, then what is the yp? So 1 upon d square plus 1 cos hyperbolic 3x. Correct. We replace d square by plus a square now, plus 9. That's correct. Good. And this is the answer. That's very good. So the answer is 1 by 10 cos hyperbolic 3x. That's the correct answer again. 13. Solution of, this is the Cauchy's form. I think this type of the question we already completed. And you'll observe minus d plus d square is 0. And here is the correct answer, C1 plus C2 ln x or log x. Sometimes the option may be ln x, because this log x is a natural log. Okay, the base is e, so sometimes ln x is used instead of log x. Generally, okay, so both are correct. Whenever the base is not written, by default the base is e. And whenever you want the base, you can specify log x at the base 10 or the other thing. Okay. So right now the base is not written, so it is correct. So it is a natural log. That's the answer for 13. D square minus 2. Yes, d square minus 2 is a 0, which indicates d is equal to plus or minus root 2. And here plus or minus 2 is a repeated root now. So plus root 2 and minus root 2. C1 plus C2x, and yes, that's also correct. Good. So this is the answer, because here root 2 and minus root 2 are repeated root. Root 2 and minus root 2. 15th, in the 15th we want pi for x e raised to minus x. So RHS is x into v form. So whenever there is a, no, not it is x into v. So instead of x into v, it is taken e raised to ax into v form. So e raised to ax taken outside and we replace d by d minus 1. That's correct. Good. And we get 1 by d square of x. So we want second integration of x. Yes, and that's correct. So 15th answer is correct. So we have the yp for x into e raised to minus x. Good. 16th. Now fd is a d square minus 2 given, and the question is 1 upon fd. Again yp for this one. So we replace d by 2. So it's very simple. Replace f of d is become f of a. We replace d by 2 and we get the answer as 1 by 2 e raised to 2x. This is also correct one. 17th, again yp 1 upon d square plus 5 of sine 2x. We replace d square by minus a square, so minus 4, and we get this as answer. So very simple questions are there. So these questions obviously can come in the final exam, because you can definitely do it within 1 minute. All these questions are very simple and straightforward. But the correct formula you should click within. Okay, you should get that quickly, that correct formula. 18th, we want yp for e raised to minus x again. But here when we replace d by minus 1, you will observe it is coming 0. So x is multiplied, differentiate denominator, that's correct. Again when we replace, the same thing happens. So again x is multiplied and differentiate denominator, and that's the answer. Very good. It's correct. 18 is correct. So if anyone have a doubt in the second set now, from 10 to 18, you can ask. Any doubt in the second set? Any of the question? Yes. I'm asking, is there any doubt in the second set, 10 to 18? Any of the question?
No, sir.
No doubt. Okay, thank you. Come to the third set then. I think Asif completed this. So this is 4d cube plus 4d square plus d. Again, a general solution. All questions are little bit similar, either CF or PI. You'll observe the most simple topics that you have in the exam are Laplace transform, LDE, PDE, okay, vector, and then numerical method. Why that is also simple, but it is theoretical. Some MCQs can come theoretical there. It's not numerical that way. Okay, so but if you are good in if you understood that method, then you can easily attempt that MCQs also. So here is a cubic equation. So it will have three roots. Now important task is how to get that roots. You scientific calculators allowed. I number of times I told roots can be calculated on calculator also. You should learn the method how to get the roots. And here minus half, and 0. These are the roots. So this is the answer. Okay, that's correct. 20th, d square plus 4 of y is a cos 2x. Then what is a yp? Okay, so here written directly the answer, that is 1 by 4 x sine 2x. Okay, so yes, this is the correct answer, I think, because you will clearly observe the method says yes. What is the method for trigonometry? We replace d square by minus 4. If you replace minus 4 plus minus, it becomes 0, multiplied by x, differentiate this denominator, differentiate d square plus 4, it becomes 2d of cos 2x. And now this x as it is, x by 2 as it is, 1 by d, integration of cos 2x. What's the integration of cos 2x?
Sin 2x, right?
Yes, correct. And that's the answer. 1 by 4 x sine 2x. So even though it is not written detail, yes, it is of 1 or 2 step only. 21th, by method of undetermined coefficient, what is a trial YP? What is a trial YP? Obviously, RHS is a 12x square, so a plus bx plus cx square. We discussed that already. In the equation, dx by dt plus y is equal to sin t plus 1 and dy by dt plus x equal to cos t. If y is equal to sin t plus 1 plus e raised to minus t, then what is x? Okay, so you can clearly observe this is the value of y, and this value of y, if you replace here as a dy by dt, you get x. You get x because just calculate dy by dt, replace it here and simplify it for x, and you will get the answer. Okay, you can do that. Then here x square d square plus xd plus 7 plus y equal to, we convert this linear with a constant coefficient. Okay, just you have to convert it to the constant coefficient. Now the answer is written in variable t. Our answer generally we are writing in the z form. Okay, so this is just we have to convert in constant coefficient. To do this question, you will observe, first of all, we use some substitution. Generally we say that x is e raised to z. But if your answer is given in t form in MCQs, then you have to consider z as a t at the end. So generally we use this substitution, x is e raised to z. So when x is e raised to z, this x square d square become d into d minus 1 plus xd becomes just d plus 7 as it is of y is equal to, now what is 1 by x? 1 by x is e raised to minus z. So 2 into e raised to minus z. Okay, e raised to minus z. So that about the LD with a constant coefficient. Just you have to write in simplified form. This is d square minus d plus d gets cancelled. D square plus 7 of y is equal to 2 e raised to minus z. So this is the answer. The answer can be written in this form also. This capital D is not right now. It is not d2y by dx square. It is not d2y by dx square. It is a d2y by dz square, because z is independent variable now, because we replace x by e raised to z, we change variable x to z now. So this d is new d, actually it is a transform d, and this d is different from the original d. So some authors are using here d dash. Okay, so that is also okay if you are confusing with the notation d there. So this capital D is a d2y by dz square plus 7y 7y is equal to 2 into e raised to minus z. So that is the answer. Now here the answer is written d2y by dt square plus 7y is equal to 2 times e raised to minus t should be there. Okay, or some maybe he written there, but it may be under that line. So is it clear? Any doubt? Any doubt in this question? The question is just write its corresponding LD with a constant coefficient. Okay, so original differential equation is variable coefficient. It is Cauchy's form. So just convert Cauchy's form to the LD with the CC. Any doubt in 23rd?
No, sir.
No. Okay, good. 24th is here. So again, the direct answer is written, but here we want to YP for this one. And yes, whenever it is a algebraic function, remember, yes, we get yp like this. Yp is equal to, we take a lowest degree term common from d square plus d. The lowest degree term is a d. So if you take d as a common, you get 1 plus d or d plus 1 of x square plus 2x plus 4. Sorry, just a minute. This happened. X square plus 2x plus 4 is there. And now first you have to this 1 by d operator you can keep as it is, and this is 1 upon 1 plus d, which can be taken as 1 minus d plus d square. Now I don't want to write minus d cube because third derivative of this term is 0. It is a quadratic equation. So we stop this expanding because 1 upon 1 plus d is 1 minus d plus d square minus d cube plus d4 and so on. So out of that we taken only quadratic because of a linear term. And now 1 by d kept as it is, and if you take inside, it is x square plus 2x plus 4. Just we multiply this bracket to the 1 minus that derivative of the bracket. The derivative of the bracket, this is 2x minus 2 plus second derivative of the bracket, so this is 2x plus 2. That's one. So out of that, minus 2 plus 2 gets cancelled. Minus 2x plus 2x gets cancelled. And we left x square plus 4. And integrating, this 1 by d is still outside. So if we integrate, the x square integration is x cubed by 3. And 4 integration is 4x. And that's the correct answer again. Okay. So that way you have to do it. It is algebraic form. And we know how to deal with the algebraic form. 25th, the solution for this is the second order differential equation. Now this question have both CF and PI. So if by chance the questions comes like this, you'll observe this first part. This first two terms gives us a CF, and this last part is a PI. So you have to calculate everything. You have to calculate everything for 1 mark there, for 1 MCQ. So it may happen that now if the question come from this book, textbook, and suppose this question is selected, and you should know that this is the complete solution is asked, and you have to highlight the correct answer. So LHS gives you the CF and RHS gives you PI. So then you can proceed there. 26th, now again PI we want, PI for this, so only RHS you have to solve and you get this as answer. Probably this x is multiplied, that indicates plus 1 and minus 1 are the roots of the LHS, and because of that this x appeared there. Okay, so that about 26th. 27th, this is the following is a complementary function of the differential equation. So again Cauchy's form given, and we just want a complementary function only, so don't think on RHS. Okay, so log x, just you can ignore it. And actually he written wrong also when he converted in Cauchy's. When it is converted from Cauchy's to the LDE, this will not remain log x, so just ignore it, write it 0. This will become actually as z is e raised to x, so log x becomes a, okay, you have to find out the log x value if you want that, but RHS is not correct. So x is e raised to z, so log e raised to z, this is just z. Okay, RHS is just z there, not log x. And I think CF is also not correct. What is the mistake he made? Yes, anyone? What the mistake he made in the CF?
E power Z and
Yes,
X.
yes. First of all, he should write the answer in terms of z, and then it should convert it in the x. So the corrected answer for this question is first of all the answer is a C1 plus C2Z, C1 plus C2Z e raised to Z, and replace Z by log X. Is it Z is log X or X is e raised to Z? So Z is log X, correct. So the correct answer is a C1 plus C2 ln X, and e raised to Z is X. So this is the correct answer. This is the CF. This is the CF for that question. So any doubt in the third set? So there are small, this is the, I think, small two mistakes we observed. This is one last question. If you want the CF of the original equation, then this is the correct answer. And if you want the CF of transformed equation, then this is the answer. This is the CF of a transformed in variable Z. But the answer, if given, if the options are available in variable X, then this is the correct answer. Okay. So come to the last set then. I think last set completed by Ankur. So here question number 28. The auxiliary equation have the root +1 and -1, and we want homogeneous linear, and we want LDE there. Homogeneous linear differential whose auxiliary equation. I think somewhere he made a mistake. Why x is multiplied here? Is there that in the options? Homogeneous linear differential equation whose auxiliary equation is +1 and -1. That's a given. So so is it given answers option? If the options available in the Cauchy's form, then that's okay. But if the answer options are available in normal form, then your answer should be, there should be the answer. This one is your answer. That's one only. Like d2y by dx square, d2y by dx square minus y is equal to 0. So this is the differential equation. This is the differential equation whose auxiliary equation have the root 1 and -1. So that should be the correct answer. I think Ankur is in this division or the other. What are the options? Anyone knows? Anyone knows what are the options there?
There are no options.
There are no options. Okay. If there are no options, then it is not correct. Then obviously it is not correct. So this should not write. Okay. This should not write. This is the answer only, because we want the homogeneous LDE. So all differential equations are homogeneous. Why they are homogeneous? Their degrees are 1. So what is the degree of y? So you'll observe this is the degree of y, that is 1, and degree of d2y by dx square, that is also 1. So each term have the degree 1. So they are homogeneous LDE. Okay. So just you have to find out a linear differential equation. Don't confuse with the word homogeneous. Just you have to find out linear differential equation which have the root 1 and -1. So the answer is d2y by dx square minus y equal to 0. And if you see the auxiliary equation, the d square minus 1 equal to 0, and you get that root. That's one. Okay. Good. Question 29. We want yp for I think log 2 is on the RHS. Okay. So even though log 2 is there, you should not worry. This is just a constant, and whenever the constant is there, you should replace d by 0, and that's correctly done here. So 1 by 9 log 2 is the correct answer. That is correct answer here. Question number 30. We are given to transform this differential equation into a linear differential with constant coefficient. Put x equal to. So we generally put x is equal to, yes, x equal to e raised to z, or you can take x equal to e raised to t. That's the answer. So just you have to write what you have to put it. Yes, x is e raised to z, correct. So it is in Cauchy's form. So either you put x as a e raised to z if the option is available and that's written in variable t, then x is e raised to t. X is e raised to t is the answer there, provided it is given the option in. So you can write in any of the variable. You can put x as a e raised to z, x as a e raised to t. You can put x as e raised to q. Okay, any variable you can select. Choice is given if it is not given. But if it is in the option, some variable is given, you have to select that only. 31. We want pi for sine 3x. It's one of the simple question. Just to replace d square by minus 9 and the correct answer is there. This is one of the simple question. 32. The differential equation whose auxiliary equation has the roots 0, minus 1, 1. Now again, probably he made same mistake. Let me see. If 0, minus 1 are the root, then factors are d plus 1, d plus 1. That's correct. Okay. So d into d plus 1 bracket square. And this is d cube plus 2d square. And that is the answer. This is the answer. That's correct now. Now he done it correct. Why written doubt? I don't know. But whatever he written, that's correct, because if in the book they are giving the Cauchy's equation as answer, that's not correct, because this is the differential equation. This is the differential equation whose roots are 0, minus 1 and minus 1, and you can clearly observe we gone in the reverse way here. Okay, that's correct answer here. Any doubt here? This question? No. Okay, the answer here, he says it's written d cube y by dx cube plus 2 equal to 0. It is impossible now, because you will observe clearly this is the cubic equation and middle terms are not present. You will get a complex root there. You will get complex root for this equation. So this is the wrong answer given probably in the book only. So sometimes there are the wrong answers in the book. So whatever he written, that's a correct answer. Okay, that's a correct answer. D cube plus 2 will definitely not have the root as a d equal to 0. Okay, this differential equation straightforward. This differential equation straightforward doesn't have the root as a 0. This have the 0 root, because we want the roots as a 0, minus 1, minus 1. So this is the correct answer. That's all. 33. We have the cubic equation here, and for this cubic equation we want a CF probably. Yes, it's a CF only, because RHS is a 0. So all the three roots are calculated and the answer is written. So that's correct. So whatever YC is there, that's itself a complete solution. C1 e raised to minus x plus C2 plus C3x e raised to 2x. That is correct one again. Okay. Question 34. We are given Cauchy's form again, as it is Cauchy's form, and we want to YC. So we replace this and we get a root here, and this is the answer correct? Is the answer correct? Is the answer correct? Quick, quick. Am I audible? Is the answer written by him Corey is correct or not? Here is the differential. That's correct. How it is correct? Huh? You will see these are the roots. If these are the roots here is getting, so your answer should be in terms of z, na? Because it is a transform. Whenever it is a Cauchy's form, you should be careful. YC should be C1 e raised to 1 plus root 2z plus C2 e raised to 1 minus root 2z. And now you can replace z by log x. If you replace z by log x, your answer, the final answer should be, I will write it here only then, C1. If it is a z is a log x, then this is a x raised to x raised to 1 plus root 2 plus C2 x raised to 1 minus root 2. That should be the correct answer, is it? The correct answer should be C1 x raised to 1 plus root 2 and plus C2 x raised to 1 minus root 2. I hope you are getting what I am saying. So your answer should be in terms of z first whenever it is in Cauchy's form, and then you should resubstitute the value of z. Then only you will get the answer in terms of x there. 35th. D square minus D minus 2 is 0. The general solution, we want general solution. So is it true or false? Yes. So what he done, he got the roots. The roots are coming 2 and minus 1. So the correct solution is a C1 e raised to plus 2t and C2 e raised to minus t, and they are given in the reverse in the sign. So because of that, whatever the general solution, that's a false there. And 36th again, 1 upon fd of x square e raised to ax is 1 upon d plus a of e raised to ax x square. So e raised to ax should be taken outside, that's correct here, and because of that it's written false. Correct. Good. So all the remaining questions are correct. Again, there are only one or two small mistakes there in the last set. Otherwise, all are correct. If anyone have any doubt in any of the question from 1 to 36, you can ask. Yes, any doubt?
No, sir.
No doubt.